In this video, I'm gonna talk about HSRP. HSRP is one of the first hop redundancy protocols. So the others are VRRP and GLBP. But in this video, we're gonna just talk about HSRP. But you can also apply the same concepts to VRP, which is open standard. So HSRP is a Cisco proprietary protocol developed to allow several routers, or I'm reading this part here. Let me just zoom in. So HSRP is a Cisco proprietary protocol developed to allow several routers or multi-layer switches to appear as a single gateway IP address. So of course, for redundancy purposes. So that's why it's called hot standby router protocol. So I've got this is how a router becomes the active router or the standby router. So each router will participate in the active or standby router election, and the HSRP election is based on a priority value. So here 0 to 225. So by default, priority is set to 100. The router with the highest priority value, 255 is the highest, becomes the active router for the group. And if the routers, for example, this router is here. I'm not sure if you can see it. If these two routers have the same priority, the tiebreaker will be the IP address that is configured on the HSRP interface. So as you can see here. So let me just. So in this case, if these two routers here have the same priority, or their priorities are equal, the router that has the higher IP address on the HSRP interface will be the active router. So in this case, this router has the highest IP address, which is 100.1.1.1.253. So this will become the active router. So, and I've also listed the HSRP states. So let me just zoom in again. Oh, here. So initial. So there are 5 states or HSRP states. So initial, the state of an HSRP state after it has been configured, or it has come up. And number 2 is listen. The state of an HSRP interface after the router knows the virtual IP address and the interface, or the HSRP interface, is listening to hello messages, of course, from the other routers. Number 3 is speak. The state of an HSRP interface when it is sending hello messages and is participating in the active standby router election. And number four, standby, the state of an HSRP interface when the router is the candidate to become the next active router and is sending hello messages. And number five is, of course, the active state. This is the state of an interface or of an HSRP interface when it is forwarding packets and is sending hello messages. Of course, I got this from, of course, my reference is this book. So, like I said, HSRP is one of the first hop redundancy protocols provide uh, redundancy for a gateway IP address, right? So let's talk about. I've actually created a topology here, so we can so I can show you um, how we can configure HSRP and how it works. So let's say that this router here is the active router, and this router here is the standby router. I've actually configured these routers before I made this video, so I'm just gonna show you the configurations that I did. And this switch here is just layer 2 switch. There's this I didn't configure this switch. I just connected a PC to that switch, and of course let's just say that um, this is the ISP router, and actually there is I created a loopback address. Loopback 0, and the IP address is 1.1.1.1. So let's say that this is some IP address on the internet, so we can actually ping this later from this PC and see if which path are we traversing to get to that IP address. So let's take a look at the configuration of the active router, or I actually named it as BR router. So let me just do a show IP interface brief. So as you can see, this is of course gigabit 0/0/0, and this is the IP address of the router at 100.1.1.252/24, and standby router has an IP address of 100.1.1.253/24. They are both on the same subnet, and also this PC. They are all on the same subnet. So this is the IP address, as you can see here, and of course the gig 0/0/1 has an IP address of this and /30, so 172.16.1.1/30, and the other side is .2/30, and of course the IP address of the standby router here on this interface is 172.16.1.5, and the other side is .6, so /30. So let me show you the configuration, or the HSRP configuration. Looks like here. So this is the configuration. So this is the port facing this switch here. So basically, this standby, this is how you configure HSRP. Instead of saying HSRP, you say standby. Unlike VRRP, you say VRRP, or GLBP, you say GLBP. But take note that with HSRP, you say standby, not HSRP. So standby 21, this is the group number, and IP, this is the virtual IP address, and this is how you configure the priority. And like I said before, priority is set to 100 by default. So I'm making the priority of this router higher than 100, so it will be the active router. So pretty simple configuration here. Let's take a look at the standby router. So here, so as you can see, this is the IP address of that interface facing this switch here, layer 2 switch. And by the way, this is actually a multi-layer switch, so but I'm just using it as a layer 2 switch. So, and this is the IP address on gigabit 0/0/1, the IP address of that interface rather. So let me show you the configuration of the HSRP configuration on the interface facing our LAN network. So here, so they have the same. So in this case, they have the same priority. And by the way, this is the IP address. Each router has their own unique IP address on their interfaces. So in this case, let me just show you this. In this case, here 252, and on the other side 253, and the virtual IP address is 254, both 254. But as you can see here, they have the same priorities. So like I said earlier, if the priorities are the same, the tiebreaker will be the IP address that is configured on the HSRP interface. So in this case, BR2 should be the active router. So let's verify that. Standby. Type standby. So yeah, it's correct. Standby state is active. So the tiebreaker here is the IP address, because this router has a higher IP address than this router, which is just 252, and this is 253. I hope you can see my cursor, my mouse cursor. So I'm gonna actually configure this router as a standby router. This is supposed to be a standby router. So standby 21 priority. This is supposed to be, I'm gonna remove this so it will have the default priority, which is 100. So let's check again the configuration. Yeah, so if we check now, standby so still standby. You know the reason why, because preemption is disabled on the interface. So router 1 or PR1 is not gonna take over the active role, because on both, preemption is not enabled on both routers. So let me enable the preemption on both routers. So standby 21 preempt. So also here. Standby 21 preempt. As you can see here, this router has become the active router because it now has the higher priority. Let me save the config. So let's verify. So this is now the BR1 is now the active router, and BR2 is now the standby router. So here, and you can actually see more details about HSRP by doing a show standby on the router. So this is the virtual IP address, like we saw here. This is the virtual IP address here in the middle, and now preemption is enabled. Standby router is local. Priority is 100. Default is 100. You can also do a command interface, or brief, actually brief. So let me do a brief show standby brief here also. So here, this is the virtual, this is the interface group. Priority is 100. Active local standby. This is the IP address of the standby router, and this is the virtual IP address. So now we have verified that this is the active router. So now we can actually verify from the PC here. I also configured this PC like this, static. This PC has a static IP address. So this is subnet mask, default gateway, and DNS server, Google public DNS. So let me go to the command prompt and see if we can ping the IP address of this router here, the loopback address of this router here. So this is just to simulate that we can get to that IP address. So let's just say that that is somewhere on the internet. Okay, I guess we can ping. Yeah, request timeout. It's because of the ARP. So let me try to do a ping again. Now it's all successful. So uh, let me show you, or let us verify which path are we choosing to get to that IP address. So this is a Windows, so you should use tracer, the tracer command instead of the trace route. So 1.1.1. So as you can see here, it's choosing this link here because this is the active router to get to 1.1.1.1. And you can also verify that that this PC is getting the the virtual MAC address of the virtual IP address. This is the virtual MAC address of the virtual IP address. So you can, I actually showed you this earlier. So here they should have, where is that window? So BR1, BR2. So these routers should have the same virtual MAC address. So here, yeah, they are the same. And if we go to the PC, it should be the same also here. So there you go. That's how you configure standby, I mean HSRP, and that's how you can verify if your configuration is correct.